Hi, my name is Dana Golden. Today we're going to continue on with the overview of environmental macroeconomics with a look at the Solow growth model with natural resources. So if you've seen intermediate macro, you've probably seen the Solow on growth model, which looks at how economies grow over time, and we're just going to add natural resources to that with a focus on how resource constraints impact long-term growth. If you'll recall, in the Solow growth model, there's not really a look at resource constraints. There is really just this idea of here's how much capital you have, here's how much labor you have, you want to grow capital over time with investment. Here we add the resource constraints to make it to help understand how resources interact with production. So traditionally in the Solow growth model, it would end here. We'd have the parentheses here. We're adding a resource input under the assumption that resources are necessary for production, meaning that FR is greater than 0. So we're assuming there's an exhaustible resource, something like oil or coal that's depleted over time, and that growth depends on the rate of technological progress and also the rate of resource-saving innovation. So GDP, Y of t, is equal to A of t times K of t raised to the alpha, L of t to the beta, R of t to the gamma. So now we've added a resource to the model and basically made the idea that resources are valuable and you need to maintain them to maintain macroeconomic growth. R of t decreases over time unless offset by efficiency gains in A of t. This is a big change to the macroeconomic model. Capital is endogenous in a macroeconomic model almost always. So you choose how much to save and how much to spend of your capital. Labor is usually exogenous. There's not usually a variable that goes down on its own. Resources are a very different breed, and most macroeconomic models traditionally did not think about them. And so sustained growth requires that the rate of destruction of the resources is less than the alpha plus beta, because you need to take less from resources than the other goods. So resources generate naturally, but growth depends on maintaining the resources as regeneration above depletion. So you have some sort of regeneration rate where the resources tomorrow are equal to the resources today times the regeneration rate minus the extraction rate. And for there to be sustainable growth, you need that the extraction rate times the resources that the regeneration rate times the resources is greater than or equal to the extraction rate. Basically, you're taking out resources at a slower rate than they're regenerating, or the same rate. Right now, we're taking them out at a higher rate, and that means not only that the environment's degrading, but also an important reason why this is valuable is because it makes the point that actually it's just not sustainable to have an economy where you're hurting the environment. At some point, you have to not only live within your budget constraint as a consumer, but you have to live in your budget constraint as a nation in terms of the environment and make sure that you're protecting the growth of your natural resources. So how do we think about technology in this case? How do we think about green technologies and policies decoupling economic growth from environmental degradation? So here we focus on decarbonization, resource efficiency, and what we do is we tie emission to production, where sigma T is emissions efficiency. So this version of the Solow model, now we have the ability to create emissions. So now you build on the former framework, and you have this net as exhaustible resource, but now you also have an emissions intensity, and you can choose how intensive to create your technology. So emission intensity decreases over time with green technology, so you make investments in green technology or less green technology, and growth can occur without proportional emissions growth by making these investments in this phi, making these increases in green technology. In this way, green technology offsets resource constraints, and policies promoting decarbonization accelerate sustainable growth. So the implication of this model, whenever you create a model, particularly in macroeconomics, you want to think about what the results are. For Earth's takeaway, investment in green technologies is crucial for long-term growth. So in the first version of that model, you had no green technologies. You basically were going to deplete your resources in the long term. You need to improve technology for the kind of growth that the world is going to view. And then you can also reduce emissions intensity by carbon taxes and subsidies for renewable energy and energy efficiency. Basically, this is the argument that we have some control over how much we invest in environmental technologies. As you saw in the model just now, if you allow people to invest on their own, they might not make the investments they need in the technologies to create innovation. So whatever you can do to do that is not just good for the environment, but can be good for the economy. So yeah, there's been a lot of green innovation that has reduced carbon intensity already. So that was the green Solow on growth model. Now we're going to talk about the environmental Kuznets curve. So we're going to try to examine the relationship between environmental development and environmental degradation with the hypothesis that environmental degradation first increases with income and then decreases after a certain threshold. So environmental Kuznets curve is an inverted U shape. It's a lot of things in economics that are like this, and basically the idea is it starts increasing and then it starts decreasing. The most famous of these is the Laffer curve, though it was in no way started by Art Laffer. And higher income levels lead to cleaner technology and stronger regulations. So countries start off pre-industrial with their low income with minimal pollution, and then they industrialize with rising income and increasing pollution. And then after they industrialize, they have high income, decreasing pollution due to cleaner production regulations. So there's the Kuznets curve. You can see there's, in developing economies, there's this increasing inequality. Then you have this turning point, and then you have decreasing inequality in developed economies. Get rich or die trying, you have this increasing inequality, you have this increasing use of resources, this increasing hurt of the environment, and then when you get rich enough, you start making the economy more sustainable for the environment. So how does this work? Economic growth increases reduction in resource use, which leads to higher pollution. So as an agricultural economy, you're probably not doing things that are bad for the environment. As you grow and become more developed, you build a factory, you pump coal, carbon dioxide into the air, and then you lead to higher pollution. Then structural shift from heavy industry to services and clean industries as you become more developed. And then you have the adoption of cleaner technology and stricter environmental regulations in high-income countries that can afford to demand better environmental quality. And you see this not just on the scale of like better environmental quality. You see this on the scale of how people think about a lot of things in macroeconomics, in particular the impact of growth on inequality. In China right now, you're seeing the growth of middle class following development and move out of newer industries. Criticism of the environmental Kuznets curve, obviously global pollutants. It's not really as applicable for pollutants like CO2, which accumulate globally, and where you kind of have not seen the rich world stop polluting that much. They're still very large polluters. A lot of rich countries actually are just shipping the pollution elsewhere. They're taking the emissions they're producing and they're pushing it somewhere else. There's varying levels of effectiveness of the evidence for this, and then the decline in pollution is driven by regulations, and it's not always clear that this is related to income. I think the biggest criticism of the environmental Kuznets curve is that I think in many ways it can be used to justify the idea that countries like the United States will just get rich, or countries around the world will just get rich, and then pollution will stop being a problem. But the problem is a lot of that carbon dioxide emissions and a lot of the emissions are already done, and that's still a very big problem. So some policy implications of the environmental Kuznets curve. Economic growth is not sufficient to address environmental challenges, but it's important to invest in green technologies, enforce environmental regulations, and coordinate internationally to address global pollutants, while also developing and supporting developing countries to develop so that the pollution can become more sustainable. So local pollutants like sulfur dioxide, particulate matter, really quite often follow the environmental Kuznets curve pattern. You'll notice that rich countries like the United States don't have pollutants in their water supplies, and they don't tend to have smoggy air. But global pollutants are pretty heavily correlated with income. We're seeing maybe that the United States is going to stop emitting as much. Maybe we've already peaked in terms of emission. But in actuality, in a lot of ways, there's a lot of questions as to how the environmental Kuznets curve works for CO2 emissions. So yeah, I'll leave as a case study, as an exercise for you. Think about, and maybe this should be your project if you want it to be, if you're very interested in this for the class. How should you compare emissions trends in developed versus developing countries? And how should we think about who bears the costs? Have a great day, and I'll see you next time for a look at integrated assessment models.